So what we're going to talk about today is we're going to talk about coterminal angles in section 1.4. So some of you may have already started asking yourself this question, well, this angle actually can be described a couple different angle measurements, and that's exactly what a coterminal angle is. It's an angle that has the same initial side and same terminal side, but are different measures. So for degrees, all you need to do to find coterminal angles is you're going to add or subtract 360 degrees. You may have to do this multiple times if you want to find a positive or negative angle measurement. For radians, so again, in degrees, you simply add or subtract 360. To find coterminal angles in radians, you're simply going to add or subtract 2 pi. Just like with degrees, you may have to do this multiple times. It's impossible to find all the coterminal angles for one angle. One angle has an infinite number of coterminal angles. So we have to find all the coterminal angles, you have to make a generalization. So for degrees, it's going to have to be theta plus or minus 360 degrees times k. And k just represents an integer that you would plug in. So like a -1, 0, 1, 2, etc. So you could take an angle and add 360 times 2 to it, or an angle plus 720. In radians, it would be theta plus or minus 2 pi k. Some books may use an n, but it's just an integer. So like I said, if you have, let's say, an angle, for example, in quadrant 1 that is 60 degrees, you could say one coterminal angle would be 60 degrees plus another 360. So if I took 360 plus 60, that's going to give me 420 degrees. So 420 degrees is an example of a positive coterminal angle for 60 degrees. I could also find a negative angle measurement. So for example, if I go in the negative direction, so if I take 60 degrees and I subtract 360 degrees, that's going to give me negative 300 degrees. So negative 300 is the negative coterminal angle for 60 degrees. 420 is a positive coterminal angle. I could make 2 revolutions, do 360 plus 360 plus another 60, and that would give me a coterminal angle. So find one positive and one negative coterminal angle for each angle in standard position. So here's 0 degrees. So all I need to do to find a positive coterminal angle, I'm just going to abbreviate positive coterminal angle as PCT. I'm going to take 0 degrees and add 360 degrees to it. So 360 degrees is a positive coterminal angle. A negative coterminal angle is going to be 0 degrees minus 360 degrees. And that gives me negative 360 degrees. So there's my positive negative coterminal angle for 60 and 360. And I actually just did 60 degrees up here in this example. So again, my positive coterminal angle can be found by taking 60 degrees plus 360 degrees. That's going to give me 420 degrees. My negative coterminal angle is 60 degrees minus 360, which is negative 300 degrees. Okay. So that's how you find coterminal angles for angles that are in degrees. So in radians, remember, you're going to add or subtract 2 pi. So again, to find my positive coterminal angle, I know I'm going to add fractions together. So again, with a denominator of 4, I know that 2 pi is equivalent to 8 pi over 4. So I'm going to take 7 pi over 4 and add 2 pi, which is 8 pi over 4. And that's going to give me 15 pi over 4. So there's my positive coterminal angle in radians. My negative coterminal angle, I'm going to take 7 pi over 4 minus 8 pi over 4. That's negative pi over 4. So there is my negative coterminal angle for 7 pi over 4. Now for 880 degrees, since 880 degrees is larger than 360, I'm probably going to have to add or subtract 360 several times to get me down to that negative coterminal angle. So for example, to give me a positive coterminal angle, I'm not going to add 880 to 360. I can, but notice if I subtract, That's going to give me 520 degrees. That's still a positive angle measurement, so 520 degrees is indeed a positive coterminal angle for 880. So if I take 520 and subtract 360 again, that's going to give me 160 degrees. 160 degrees is also a positive coterminal angle for 880 degrees. Now to find the negative coterminal angle, notice I've been subtracting 360 and subtracting 360. So now what I'm going to do is I'm going to take 160 degrees and subtract 360 from it, because I need to have a negative angle measurement. So that's going to give me negative 200 degrees. So sometimes you may have to add and subtract a couple times to get that negative angle measurement. So 7 pi over 6. So again, in radians, I'm going to have to add or subtract 2 pi. So again, 2 pi is equivalent to 12 pi over 6. So I know I'm going to be adding, subtracting fractions, so I just went ahead and got that common denominator. So my positive coterminal angle, I'm going to take 7 pi over 6 and add 12 pi over 6. That's going to give me 19 pi over 6. My negative coterminal angle, I'm going to take 7 pi over 6 and subtract 12 pi over 6, which gives me negative 5 pi over 6. So there's my positive and negative coterminal angles for 7 pi over 6. So now negative 415 degrees. So I know that negative 415 degrees is going to be more than one revolution around. So to find a negative coterminal angle, I'm going to take negative 415, and instead of subtracting 360, I'm going to go ahead and add 360. So negative 415 plus 360 is going to give me 55 degrees. So negative 55 degrees is indeed a negative coterminal angle for negative 415. Now to find a positive coterminal angle, notice I added 360 and I still do not have a positive angle measurement. So I'm going to take negative 55 degrees and add 360 degrees again. So negative 55 plus 360 is going to give me 305 degrees. So there's my positive coterminal angle. So here is my angle in radians. Again, negative 11 pi over 4 is going to be more than one revolution around. So what I'm going to do is I'm going to have to may add or subtract 2 pi more than once. And again, because I'm adding fractions, let me get that common denominator. So I know that 2 pi is equivalent to 8 pi over 4. So then to find my negative coterminal angle, I'm going to take negative 11 pi over 4 and add 8 pi over 4. That's going to give me negative 3 pi over 4. My positive coterminal angle, notice I've already added 8 pi over 4. I still have a negative angle measurement. So I'm going to take negative 3 pi over 4 and add 8 pi over 4. So that's going to give me 5 pi over 4. So there's my positive coterminal angle. The idea is you want to find the smallest positive or negative coterminal angle as possible, either between 0 and 2 pi or 0 and negative 2 pi. So there are how you can find coterminal angles, whether you are in radians or degrees. So for the next set of examples, not only am I going to find one positive and one negative coterminal angle, but I also want to find all the angles. So that's where I'm going to write that generalization. That's the formula I can use to calculate all of my coterminal angles. So 70 degrees is located right here in quadrant 1. So to find my positive coterminal angle, I'm going to take 360 degrees and add it to 70 degrees. And that's going to give me 430 degrees. And what that is, it's one revolution around plus another 70 degrees. To find my negative coterminal angle, I'm going to take 70 degrees and now I'm going to subtract 360. So 70 degrees minus 360 is negative 290 degrees. So that is this angle going in the negative direction. My generalization, or the formula to find all of the coterminal angles, I'm going to take 70 degrees plus or minus 360 degrees times k. So now negative 5 pi over 3. Again, I'm going in the negative direction. So that's going to land me all the way up here in quadrant 1. So then to find my positive coterminal angle, again, remember, I'm going to have to add and subtract 2 pi. So I know that 2 pi is equivalent to 6 pi over 3. So I'm going to take negative 5 pi over 3 and add 6 pi over 3, which is pi over 3. My negative coterminal angle is negative 5 pi over 3 minus 6 pi over 3, which is negative 11 pi over 3. My generalization is taking negative 5 pi over 3 plus or minus 2 pi k. That's the formula I can use to find all of my coterminal angles. So this pi over 3 that I found is this angle right in here. This negative 11 pi over 3 is if I make one complete revolution. There's my negative 6 pi, and then I go another negative 5 pi over 3. There's the negative coterminal angle. Negative 190. So negative 190, when I sketch that angle, is going to be up here in quadrant 2, because again, if I make this rotation around, that's 180, and then I go another 10 degrees. So there's negative 190. So my positive coterminal angle is going to be found by taking negative 190 plus 360 degrees. So that's going to be negative 190 plus 360, that's going to be 170 degrees, which is this angle right here. That's the angle that you just found. My negative coterminal angle is negative 190 minus 360 degrees. And that's going to be negative 540 degrees. Maybe all right. Maybe 550, I think. Hold on. Good grief. Can't do my math right now. 550, I thought that was right. Wrong. 550 degrees. And that's, again, I'm going to do my negative 2 pi revolution, and then go another negative 190. And that's that negative coterminal angle that I just found. Now be careful, radians can be measured as approximate or exact. There is no degree symbol here, so this is an approximate radian, meaning that they've multiplied out the pi. But you're still going to find your coterminal angles in exactly the same way. Oh, I'm sorry. My generalization for part C for negative 190 is negative 190 plus or minus 360 degrees times k. So now if you look at your unit circle, this is 0. I know that this is pi over 2, and as an approximate radians, this is 1.571. That's the pi over 2. That's what pi over 2 is equivalent to an approximate radians. We know pi is 3.14. 3 pi over 2 is 4.712. And 2 pi is 6.283. So even though this is approximate radians, you're still going to add or subtract 2 pi. So 3.89 is an angle that's going to be down here in quadrant 3. So to find my positive coterminal angle, this would be a calculator question. I would take 3.89 and I'm going to add 2 pi. But I'm going to multiply it out on my calculator. $10.173. My negative coterminal angle is going to be 3.89 minus 2 pi. negative 2.393. And then my generalization is going to be found by taking 3.89 plus or minus 2 pi k. So you still add and subtract 2 pi even though that is an approximate radians. So this 10.173, I would 2 pi, and then I'm going another 3.89. So there's my positive coterminal angle. This negative 2.393 is right here. So that's how you find positive and negative coterminal angles.